Ancient swimming taco had bug jaws. New fossils show an ancient bug-like sea creature with a fan-shaped tail and a carapace that wrapped around its body, swam upside down and looked like a taco, but this taco could bite back. Newfound fossils of the extinct arthropod Odaraia alata recently provided scientists with a first glimpse of Odaraia's jawlike structures, called mandibles. These small, paired appendages near the mouth bite, hold, and tear food, and arthropods with these mouthparts are called mandibulates. The first mandibulates evolved in oceans during the Cambrian period 541 million to 485.4 million years ago and include modern crustaceans, insects, and myriapods, such as centipedes and millipedes. Whether snipping, ripping, or gripping, mandibles help arthropods get the job done, and mandibulates diversified so successfully that today they make up more than half of all animal species, according to the Royal Ontario Museum. Identifying mandibles in Odaraia resolves a long-standing mystery about how the creature captured its meals and suggests that Odaraia sits among the earliest mandibulates in the arthropod family tree. Researchers reported July 24 in the journal Proceedings of the Royal Society B. Biological Sciences. The species was described in 1912 from fossils found at the Burgess Shale in British Columbia, Canada, in rocks dating back to around 505 million years ago. However, the heads of these fossils were incomplete. This left scientists uncertain of whether Odaraia belonged among mandibulates, as head appendages are critical for classifying extinct arthropods, said lead study author Alejandro Izquierdo Lopez. He conducted the research at the Royal Ontario Museum while pursuing a doctoral degree in the University of Toronto's Department of Ecology and Evolutionary Biology. For the new investigation, the researchers examined around 150 fossils collected by Royal Ontario Museum during expeditions between 1975 and 2000. Most of the specimens were new material that had not previously appeared in scientific publications, Izquierdo Lopez said. Only a couple had been published before, he said in an email. We had clear mandibles in a little bit more than 10, which shows how difficult it is to find them preserved. The preserved mandibles were previously only hinted at by muscle scars in other Odaraia specimens, the study authors reported. Odaraia's newfound mouthparts are stout, short appendages with a row of teeth, Izquierdo Lopez added. This is exactly what we would expect a mandible to look like. Their discovery underscores that even for known species, new fossils can still be full of surprises, said Dr. Joanna Wolf, a research associate in the Department of Organismic and Evolutionary Biology at Harvard University. Revisiting species that we know from before is important. In this case, the study authors had a lot of new material, Wolf said. Sometimes features are only visible on one specimen, so you should always look, prey catching leg hairs. Odaraia measured about 6 inches, 15 centimeters long and peered at its ocean home through large eyes on stalks. Its body was divided into dozens of segments, with more than 30 pairs of spindly legs. Encasing it was the so-called taco shell, a tubular shield that folded around Odaraia's body, leaving its head sticking out the front and its tail poking from the back. Many arthropods have this taco-like feature, known as a bivalve carapace, including living arthropods like ostracod seed shrimp and fan shrimps, Wolf said. The carapace folded over Odaraia's limbs, so it may have been unable to walk on the seafloor, according to the Royal Ontario Museum. Instead, the seabug taco likely got around as modern horseshoe crabs do, by swimming upside down. While its legs may not have been used for walking, they were probably important for snaring food, such as smaller Cambrian sea creatures, the researchers reported. When they examined the fossils, they found stiff, hair-like structures called seta lining the animal's legs. These tiny spines could have trapped food, much as rows of baleen in whales' mouths filter seawater and trap plankton. We think that the spines could interlock between the legs, creating a net that would capture passing prey, Izquierdo Lopez said. This type of feeding is common among many modern crustaceans, which have different types and lengths of seta that they use for food capture, Wolf added. More mandibulate mysteries. One feature that puzzled and intrigued the scientists had never been seen before in Cambrian animals, a single tooth-like structure between Odaraia's mandibles. We still don't know what it is, exactly, even when comparing it to mandibulates today, Izquierdo Lopez said. We think, though, that it was probably used together with the mandibles to chew the food further. This structure may have evolved into other similar ones in centipedes or in crabs, but we cannot say more. To date, finding additional fossils could clarify the function of this structure and may help to flesh out other unusual details about Odaraia, such as the existence of 3 small eyes between the 2 bigger ones. Prior studies briefly described these light-sensitive organs, though the researchers did not detect the rudimentary eyes in their scans. We could not see those 3 eyes very well in this study, but we cannot reject their presence completely, Izquierdo Lopez said. Future specimens may uncover an even more complex head than we have today.